All right, y'all. Last video, last topic. Oh my God, last topic. 9.10. We're talking about electrolysis and Faraday's law. So, electrolysis is when we think about plating out a solid metal. Plating out a solid metal by applying electrical charge. That's all we mean by electrolysis. Electrolysis. Okay. Now, that sounds really gnarly, but all we are going to be doing is a bunch of dimensional analysis, everyone's favorite two words. So, what are the quantitative things we need to know? Firstly, how much electrical current I am adding. Current is used, we use the variable capital I, and it's the amount of charge, which is Q measured in coulombs, which starts with a C, and that's transferred over some amount of time, right? So current is charge over time, Q over T. And I really think this is such a QT equation. Okay, so current is going to be measured in amps, so that's a unit of A. Coulombs we can measure as C, and seconds, obviously, seconds, or just S. And an amp is 1 coulomb per 1 second. Okay. Now, when we think about this quantitative relationship, we are looking at the stoichiometry, of how many electrons are involved in a reaction. And we're going to be using that Faraday's constant F, which tells us there's 96,485 coulombs for every 1 mole of electron. Right? So if we know the stoichiometry, we'll know how many moles of electrons are actually involved in this reaction. We can figure out how many coulombs are involved in this reaction. How much charge is there? Okay. Quick primer on equations. This is our last equation, OMG, I equals Q over T. You are also given these guys as a reminder, your constants. You're also given this guy. That's nice. So, and yeah, you've got these guys right here, blah, blah, blah. Okay, so this one I've got like already typed out. So if you want to just read through, you can, but I'm gonna just do it blank from here. Again, these are ultimately long dimensional analysis problems. So we're given a prompt. Gold can be plated out of a solution, right? So solid gold, we're plating it out from a solution if we add a current to it, if we pump electrons into the current. Because if you add electrons to dissolved gold, you get neutral, solid gold, okay? So we're asked what mass of that solid gold can we make in grams if we apply a 5.5 amp current for 20 minutes. And my thingy is almost out of battery. We'll see if it dies. I'll grab a charger if need be. Okay, so firstly, we're going to convert that time into seconds because amps is coulombs per second. Okay, so 20 minutes turned into seconds is going to be 1 minute on the bottom, 60 seconds on the top. Okay, now what do I do with seconds? Well, remember, an amp is a coulomb per second. To get rid of seconds, I need to put the seconds on the bottom, which means I'll put the coulombs on the top. And this 5.5 amps tells me there's 5.5 coulombs that go every 1 second. Great. What do I do with a coulomb? Well, really, the only other thing I know coulombs show up in is Faraday's constant, which tells me there's this many coulombs in every 1 mole of electrons. Okay, now I have to think about the coulombs are on the top, so I'm going to put the coulombs on the bottom with Faraday's constant. This is going to leave me with how many moles of electrons, right? If I stopped here and say, hey, you made, I don't know, 0.2 moles of electrons in this process, but that's not mass of gold, right? What else do I know about moles of electrons? I know the stoichiometry tells me there's 3 moles of electrons for every 1 mole of solid gold. Now we're getting somewhere. Okay, so there's 3 moles of electrons that are added to make 1 mole of solid gold. Now, where do I go next? If I'm looking for a mass in grams, well, I need to know the molar mass. So I have moles on top. Well, for every 1 mole that I put on the bottom, what is the molar mass of gold? 196.97 grams of gold. Okay. Plug that in and you will get an answer. Beautiful. Now, I guess technically you'd go with 1 sig fig for the 20 minutes, but I'd probably put 2 on here. So let's see. Does that track with what is written here? Yes, yes, yes. Boom, boom, boom. So 4.5 grams of gold. Pretty nifty. Now, I promise if you practice this, it's pretty straightforward, but I will say it's not always going to be like start with your unit of time, go to mass, right? Sometimes it's something like this, where I just want to know what is the charge transferred. So what is the total number of coulombs? Number of coulombs transferred. But you also have examples like this, where you're starting with a mass and then finding current. So that's a fun one. We'll do that in a second. But this example is pretty easy. So 2.5 amperes, that is actually just coulombs per 1 second. And I'm looking for the actual total charge. So I'm trying to get rid of the seconds, basically. And, well, I've given 5 minutes. Well, I know that there are 60 seconds in 1 minute. And then if I just multiply that by 5 minutes, everything cancels out. So 2.5 times 60 times 5, we get 750 coulombs total. Again, these are really just coulombs. Sorry, Rachel just sent me a cute picture of River. It says, hey, I got too milk drunk. Can you please pick me up? And it's a picture of River. That's pretty cute. Sorry, guys. Just watch your units, like good old-fashioned dimensional analysis. Seconds, gone. Minutes, gone. Top and bottom. Leaves me with coulombs. You're good. All right, last one. My last example problem would have worked for you guys. That's so sad. Okay, so we're given a mass of 10, and we're asked to find a current. What is current? Current is charge divided by an amount of time. Now, I'm told the amount of time, but I don't know the charge that was actually applied over this duration of time. So I'm just going to go from the mass of 10 and say, look, there's got to be something I can do with this. Grams of 10, right? Well, I know the molar mass is probably going to be useful. So I can put the 1 mole of 10 on top, turn it into moles. I don't know, 118.7 grams. Maybe that'll get me somewhere. Well, I do know with this whole mole thing that there's a molar ratio between the amount of electrons and the amount of moles of 10 created, right? There's a 2-to-1 ratio. For every 1 mole of 10, I'm going to get 2 moles of electrons that must have been added. Okay, now 2 moles of electrons, where does that show up? Faraday's constant tells me how many coulombs there are in 1 mole of electrons. Oh my gosh, if I get to coulombs, that's what Q is, right? That's charge. Oh my gosh. So we just need to put Faraday's constant in, make sure it's right side up so the moles of electrons cancel out. And if I stop the dimensional analysis here, right, it's going to tell me how many coulombs I have. It's going to tell me the value of Q in my current calculation. So total, I'm not going to round this really, 2,178 coulombs applied. Okay, now I want to think about my current calculation. I've got that divided by the 75 seconds to give me the actual value of I. So that number, 2178 over 75, our current is 29 amps, or 29 coulombs per second. Holy cow, you guys, we did it. We freaking did it. I mean, you should be proud of yourselves. I'm proud of you. I'm also really tired. I've been recording videos for like over an hour. So just know I love you. And yeah, can't wait to see you guys when my leave is done. Bye. How do I stop this?